Okay, if science requires experimental evidence, then we have to be able to measure that evidence, right? So if horses get bigger over time, we have to have some way of measuring the height of a horse. So at one time you used forearms, right? Back in the old days, how many forearms high is a horse? Problem with doing it that way is everybody has a different forearm, and anyway, bottom line is science, we all had to get on the same page in terms of units, right? So here in this country, we're still stuck in the English unit, right? We still use inches, and if we want to know the temperature outside, we use Fahrenheit. So the rest of the world has adapted to the SI system, International System of Units. And the way the International System of Units is organized is there are 7 base units. So really, there's only 7 measurements you have to make, and from those 7 measurements, you can derive any other unit you need to measure something. So these are the 7 base units. You have a measurement of length in meter, mass in kilogram, time in second, electrical current in amp. Temperature, we use the Kelvin scale. Amount of substance is defined as a mole. Now, luminosity we don't use in this course. It's measured in the candela. But we use all the others. Like I said, so for example, we're stuck in the English system, right? I know my weight in pounds, right? So I step on the scale in the morning, right? I weigh 185 pounds. In the rest of the world, that's almost 84 kilograms. So really, somehow we got to get used to that, right? Using kilograms. I had to use unit converter, right? I go online, you look up Google unit converter, and it gives me what the conversion is to go from pounds to kilograms. So I weigh 84 kilograms, roughly. All right, SI prefixes. So when you have a system of measurement, we have to talk about, like for example, the meter. The meter was a SI standard unit of length. That's a great unit to use to measure the dimensions of a room, but it's not a very good tool if I want to measure the distance to, say, Philadelphia. In that case, I would use kilometer. Kilometer, right? That's a 1,000 meter block. So if there's a meter stick, which is like you spread your arms out, that's like the length of a meter stick. 1,000 of those sticks would represent 1 kilometer. So that's multiples of a meter. If I want to talk about fractions of a meter, right? So if I want to measure the length of a pencil, it's awkward, right? It's a real fraction of a meter if I'm going to talk about the length of a pencil. So it's easier to use some sort of fractional value. So we can talk about centimeter, right? The centimeter is 100th of a meter. So how many centimeters long is the pencil? So different prefixes stand for the different either multiples of the unit or fractions of the unit. So, for example, what's the difference between a millimeter and a centimeter? Well, there are one, two, three. I'll use my pointer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 millimeters for every 1 centimeter. So, milli means thousandth, right? Referring to a meter. If I had a meter, I'd have 1,000 of these little ticks in 1 meter. Centimeter is a hundredth of a meter, so I'd have 100 centimeters in a meter. So that's how we use the prefixes. As I said, if you're not dealing with a standard unit, you're dealing with a derived unit. So you either multiply or divide these different base units together to derive the other units. So for example, if you notice, there wasn't a base unit for volume. Volume is a calculated value, right? So if you multiply the length of something by the width of something by the height of something, length times width times height, that gives me volume. So if I have a block that's a meter wide, a meter long, and a meter high, meter times meter times meter, I get a derived unit, the cubic meter. So 3 meters multiplied by each other is the same thing as cubing a meter. If I was talking about area, it'd be meter times a meter, then it'd be a squared meter. If I'm talking about decimeter, right? A deci is a tenth of a meter, so a tenth, 10 decimeters is the same as a meter, so 10 times 10 times 10. There are 1,000 decimeters in 1 cubic meter. A cubic meter is like the volume of a washing machine. A cubic decimeter is the same as a liter. So we're used to liters, right? A liter of Coke, right? We have the dimensions of a liter of Coke in mind. There are 2-liter bottles. Typically, we buy Coke in. Liter of Coke is the same as 1 cubic decimeter. Density, how dense something is, right? It's not how much it weighs. It's not how much space it takes up. It's both. It's how massive is it divided by the space it takes up. So I don't know. There's a joke in Monty Python. What floats in water, and the guy yells out, "Very small rocks." No. A pencil has the same density as a tree. It's a ratio. What's the mass of the object compared to its volume? So mass is measured in grams. Volume is a derived unit, cubic centimeter. So if I take cubic centimeters and divide it into grams, I get a ratio. How many grams per cubic centimeter? That's density. Temperature, as I said, the SI unit is Kelvin. We also use Celsius in this class. We don't use Fahrenheit. Fahrenheit still shows up in engineering because a lot of bridges and so on, we have to know how the bridge is going to flex, and we have to know what the temperature is in Fahrenheit. But in chemistry, we only use the Kelvin scale and the Celsius scale. And the only difference between them is where you start. The Celsius scale is based off of water, right? So water freezes at 0 degrees Celsius. So there's still a lot of Kelvin energy in that water. So there are 273 Kelvin in 0 degrees Celsius. Looking at the Celsius scale, water boils at 100 degrees Celsius. I didn't draw a line there for that, right? So 100 degrees Celsius is the same as 273 Kelvin. So it's really just where you start. -1, -2, -3, -4. When you get down to -273 degrees Celsius, that's where you start the Kelvin scale. So the Kelvin scale is an absolute scale. Really, when you're talking about temperature, you're measuring the motion of particles. So no motion at 0 Kelvin, and then 1 Kelvin, 2 Kelvin, 3 Kelvin. So there is no negative value for Kelvin. You're either moving or you're not.